So we're going to review factoring and solving. A couple of things in general. Remember that when we are solving, there's going to be an equals 0 or an equal sign in general, and we want to set it equal to 0. And our final answer is going to be x equals a number. When I'm factoring or working with expressions, there's no equal sign, and my final answer is typically in some sort of parentheses. We have lots of different methods for factoring. We always check for GCF first. If it has two terms, it's going to either be dots or SOAP. If it has three terms, it's going to be the shortcut AM trinomial, or if there is a number in front, it's the AC, where we split into four terms, and then we group, because when we have four or more terms, we always use grouping. And like I said in the beginning, remember that it's always GCF first, every single time. So if we look at number 1, I'm going to check for a GCF. Negative 9x minus 30x squared. They can both be divided by a negative 3, and they both have an x. So that's my GCF. So my negative 3x goes on the outside, open up a set of parentheses, and divide. Negative 9x divided by negative 3x is a positive 3. Negative 30x squared divided by negative 3x is a positive 10x. Remember that when you are dividing, you subtract your exponents. In this case, I can't go any further, so I'm done. Number 2, I have no GCF. They have nothing in common. I have two terms. It's either dots, which is perfect squares, or SOAP, which is perfect cubes. These are perfect squares. So for dots, we set up two sets of parentheses. One gets a plus, one gets a minus. Square root each piece. It has to stay in the order that it was given. So the square root of 100x squared is 10x. That goes in the first spot of each parentheses. The square root of 9 is 3. That goes in the second spot of each parentheses. You could also have this as 10x minus 3 and 10x plus 3. The order inside the parentheses is what's important, not whether you put the plus first or the minus first. So that was dots. Example 3. I see a GCF, so I'm automatically going to start with a GCF. All three terms are divisible by 2. And they all contain an x. So I'm putting a 2x on the outside, opening up my set of parentheses, and dividing. 2x cubed divided by 2x is 1x squared, minus 24x squared divided by 2x is 12x. 64x divided by 2x is 32. Notice how the x's divide out or cancel. Now what's left over inside can still be factored. It is a trinomial, meaning it has three terms. There's no number in front. There's technically an imaginary 1 here, but that's like when I have no number in front. We're going to use AM. I'm going to bring down my 2x, because if you don't use something, you just bring it down. Set up two parentheses. I have an x squared, so the first spot in each parentheses is an x because I'm square rooting that, or splitting it into two equal parts because there's two parentheses. Use the sign trick. Bring down the negative. A negative times a positive is a negative. I am multiplying to 32, so if you need to, go to your calculator. Y equals 32 divided by x. List out your pairs. 32 divided by x. Second graph goes to my table. I'm looking for any pair with no decimals. Because I'm working with my sign trick, I don't need to worry about the positives and negatives. So I'm going to start right at 1 and 32 is my pair. 2 and 16 is my next pair. And then 4 and 8 is my last pair. I'm looking for which of those pairs combines or adds, when I use my signs, to a negative 12. That would be 8 and 4. Bigger number always comes first when you're using your sign trick. So my final answer is 2x, x minus 8, x minus 4. Example 4, solve. So now I know my final answer should say x equals the quadratic by factoring. So I have an equal sign. It must be equal to 0 to do anything. When I am factoring or when I'm solving, I have two options, factoring or quadratic formula. This question said by factoring, but whether you're factoring or quadratic formula, you have to have it equal to 0. So my x squared is my magnet. Everything's going to move to the left side because that's where the x squared is. So I'm going to add 4x on both sides, and at the same time, I'm going to add 2 on both sides. On the right side, everything cancels. I'm left with equals 0. On the left side, I've lined everything up nice and neatly in columns based on their like terms. So I have x squared plus x minus 2. From here, I'm going to factor. It's the AM method because it's a trinomial with an imaginary 1, so no number in front. 2 parentheses. Don't drop that equals 0 because it's an equation. X goes in each. Using my sign trick, bring down the positive. Positive times a negative is a negative. I'm multiplying to 2. So my only options are 1 and 2. A positive 2 and a negative 1 because the bigger number always comes first. Remember that when you are solving, the extra step is that you have to tee off at the end. This becomes a negative 2. This becomes a positive 1. Those are my two answers. Or, if you would like, you could write it in the squiggly brackets, but no parentheses. Example 5. Factor 8s to the third minus 27. There's no GCF. I have two terms, so it's either dots or SOAP. Dots is perfect squares. SOAP is perfect cubes. This is perfect cubes, so I'm going to set up my scrap work on the side. The first thing I need to do is find the cube root of each piece. If you're using your calculator, math 4 gives you the cube root. So the cube root of 8 I need, math 4 again, I need the cube root of 27. So the cube root of 8 is 2, but I also have that s cubed, so it's going to be a 2s, and the cube root of 27 is 3. I'm going to set up my parentheses using SOAP. Same sign, I'm starting with a negative, so same sign, opposite sign, always positive. Those first two pieces from my scrap work is what I'm working with here. And that goes in the first spot of my parentheses. That second parentheses is square, multiply, square. I'm squaring the 2s. I'm multiplying the 2s and the 3 together, and I'm squaring the 3. Be careful when you square the 2s because this is really 2s times 2s. 2 times 2 is 4. S times s is s squared. So that's my first piece. When I multiply them together, 2s times 3 is 6s. And then when I square 3, I get 9. So here is my final answer for number 5. Number 6. I look, there's no GCF. I have 4 terms, so I'm going to group. These first two pieces both have an x squared that I can take out. When I divide out that x squared, I end up with 4x minus 3. My next two pieces both have a 5. You're always going to take this sign. So I'm actually going to divide out a negative 5. When I divide that out, I'm left with 4x minus 3. Notice how my two parentheses match. If your two parentheses don't match, something went wrong, go back and check. That's the first part of my answer. My other two pieces here join together in my second parentheses. You always check to make sure you can't go any further. My second parentheses here, that x squared minus 5, looks like I might be able to go further, but 5 is not a perfect square, so I cannot go any further. I'm done. Number 7, factor the trinomial. First step, is there a GCF? There's no GCF. I have a trinomial, but there's a 3 in front here, so I cannot use the shortcut of AM. I have to use AC. So 3 times 24 gives me 72, and that is now what I'm putting in my calculator to get my pairs. We set up by bringing down the two outside pieces with two blank spaces in between. Use your sign trick for those blank spaces. Bring down that positive. A positive times a positive is a positive. In my calculator, y equals 72 divided by x. Second graph going to my table. So I have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9, and then it starts repeating. So I'm going to write those down so we have them. I'm now looking for these pairs, which of them, when I use my signs, which are both positives in this case, because that's my blank spaces, adds to 22. So it should be 18 and 4. Bigger number comes first. And this time they both get an x because I'm really splitting up that 22x into two pieces. Now I have 4 terms, which means I'm factoring by grouping, just like we did in the previous question. First two, both get divided by a 3x. 3x squared divided by 3x is x. 18x divided by 3x is 6. Next two pieces can both be divided by a positive 4. Remember, you're always bringing that sign down. 4x divided by 4 is x. 24 divided by 4 is 6. My two parentheses match, so that's the first part, x plus 6. My other two pieces come together, 3x plus 4. Lastly, we're going to take a look at number 8, solve the equation for all real solutions in simplest form. A lot of times you're going to see simplest radical form, and that would be your key to use the quadratic formula. Quadratic formula will always be given to you because it's on the reference sheet. It must be equal to 0. In this case it is, so I'm going to go right ahead and identify my A, B, and C. A is 5. B is negative 18. Make sure you carry over that negative. C is 12. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. I like to set it up exactly as I have right now with blank spaces and then go back and substitute in. So b, then I have a, and then I have c. Negative 18 gives me a positive 18. On my denominator, 2 times 5 is 10. What's underneath the radical only is what goes in the calculator. So in my home screen, open parentheses, negative 18, close parentheses, squared, minus 4 times 5 times 12, and we get 84. From here, I need to break down my radical. So I have 18 plus or minus 2 radicals. If you need to, just like when we do Factoring 84 divided by x. I'm looking for my pairs. This time, once I find my pairs, not only do they need to be whole numbers, but the pair that I choose has to be a perfect square, one of the two numbers. So here's my list. I have 1 and 84, 2 and 42, 3 and 28, 4 and 21, 6 and 14, 7 and 12. The only pair that contains a perfect square is 4 and 12. I like to keep my perfect square first. This gives me 18 plus or minus 2 because the square root of 4 is 2. I can't square root the 21, so I'm leaving it all over 10. Final step is to cover up your radical and divide everything else if you can. All other terms, 18, 2, and 10, all have a GCF of 2. So I'm going to divide each of those three pieces by 2. My final answer, I'm going to write as n equals, only because the question had the variable of n instead of x's. So I have n equals 9 plus or minus radical 21 over 5. And that's my final answer.